8, 7, 6, 5, 4, 3, 2, 1. We have ignition.
We are watching a 600-ton rocket approximately equal to the weight of 150 elephants and having a length equivalent to a 16-story building transporting a satellite to its intended orbit. Launch is successful once the satellite is injected into the desired orbit. You might have also seen celebrations at the Launch Control Center after a successful launch. However, all launches need not end on a happy note. Although rare, we have heard of a few failures too. In the series of lectures explaining the functioning of rockets, this video is on how to ensure the quality of rockets, or how to determine if a rocket is fit to fly or not. I work as a scientist engineer in the quality division of ISRO. This video details on what is quality and how is it ensured in various areas of rocketry. Every launch is highly complex. Thousands of components have to work in unison at the intended time to have a successful launch. Behind every launch is the hard work of tens of thousands of technical personnel. Every launch costs hundreds of crores of rupees. Additionally, the possibilities of failures in human space missions and navigational errors in rockets leading to crashing over populated areas. These point towards the importance of ensuring quality of launch vehicles. Quality is a term we use frequently in everyday life. For example, while buying a pen, we'll think, will the ink leak and spoil the shirt? Or while buying a mobile phone, we'll think has it got all the latest features? Is it a quality item? Is it worth spending money on it? What is quality? Quality means fitness for an intended purpose. Higher quality products have greater number of features which fit with the requirements of the consumer and also have fewer defects. Long back, quality was determined by the skill of a craftsman. With the advent of Industrial Revolution, quality became a feature of the product. Now quality has become a part of the manufacturing process itself. In a way, cars, trucks, airplanes and rockets are all vehicles. However, the distance traveled, speed and complexities associated with a rocket are much higher. Rockets face extreme environment like high temperatures, pressures, vacuum, vibration, acoustics, and so on. The kind of roadside assistance and workshops for normal vehicles are not available for rockets and satellites. You might have heard automobile companies recalling vehicles in case faults are discovered. But this is not an option for satellites. Once launched, these are expected to work efficiently for at least 15 years without any maintenance. What you're watching is a crash test of a car. This is done to ensure safety of passengers and bystanders in case of an accident. Technologies like airbags are included for this purpose. When even a small car undergoes such severe testing, imagine the volume of tests on rockets. Proper performance of many complex systems have to be ensured in rockets. The structures, the engines, the software, the control systems, avionics, and stage separation systems all have to work in unison. Aeroplane accidents are several times more severe than car accidents. Still, scope for emergency landing exists. However, this is not an option for rockets, so you can imagine the importance of quality in rockets. Ensuring quality in rockets is not an easy task. Fair quality. Quality has to be ensured in design, in manufacturing, integration, mission management, launch servicing, and post-launch activities. Let's talk about quality in design. All parts are designed as per internationally accepted standards. Every design passes through a number of reviews at its various phases. Design gets finalized upon approval of various expert reviews. Weaknesses in the design are identified and corrected by a process called FMECA, failure, mode, effects, and criticality analysis. Spacefaring nations came across many failures when they started due to their inability to find these weaknesses. Ways in which a design can fail are identified and corrected. Let's talk about quality in manufacturing. Transition from drawing board to product during manufacturing is an important step. Raw materials are carefully selected through various tests to ensure quality. Details of various phases through which the material needs to pass through in order to come out as a good product is recorded and preserved. Quality of the fabrication process is also ensured. An independent agency or the quality agency ensures whether all dimensions and geometrical features of the product are as per requirements. A small fault in this process led to a GSLV failure. Diameter of a port of a fuel regulator got changed to 17 mm instead of 16 mm during fabrication. Extra 1 mm diameter led to an increase in fuel flow and thereby high temperature and pressure, and subsequently one engine got shut down. Finally, the rocket exploded and fragmented into multiple pieces during launch. Integration is the process by which systems made by different agencies are brought together to work as an integral unit. Since multiple teams are involved, proper communication among the teams is a must. To ensure the same, all changes in a design are intimated to all concerned through a change control mechanism. Failure of this mechanism led to an accident of Russia's Proton rocket in 2010. Design change after many launches resulted in a bigger propellant tank. This was not communicated to the propellant filling team. They filled propellants as they would for the previous versions of the tank. This resulted in overloading of approximately 1,500 kilograms of propellant. Rocket was unable to lift the extra mass and resulted in a mission failure. Test as you fly, fly as you test. This is the main philosophy in rocketry. To ensure proper performance of all equipment in flight conditions, these are simulated on ground and tested. For this, each system undergoes various tests like vibration test, thermo-vacuum test, etc. during its various phases. Rocket structures should withstand various kinds of flight loads. Structural test is carried out to ensure the capability of load-bearing structures. Functioning of propulsion, steering or actuation system are also verified on ground. All these tests are carried out in multiple phases: component level, system level, integrated level, etc. Avionics also get tested on ground at flight simulated conditions. Well, there may be failures in these tests, but failure is not the end of everything, is it? It is a stepping stone to success. Understanding the reason for failure and not repeating it is the key. This process is called failure analysis. It is a key step to ensuring quality. Let us remember the Challenger disaster, which led to the loss of 7 astronauts. The failure of an O-ring meant to arrest leaks was the reason for this accident. O-ring got brittle under extreme low temperatures and got displaced upon gust during the flight. This led to a leak of exhaust gases and failure of the rocket. Had this phenomenon been understood on the ground, we would not have faced this tragic accident. Quality in launch services. Safety of assembly buildings and the people working there is a very important part of pre-launch operations. All equipment used for handling rocket parts undergo a series of tests like load tests prior to start of operations. The result of these tests are reviewed and cleared by an expert committee. Quality of propellant handling systems is also ensured. Explosion at a Brazilian launch pad, which led to loss of lives of 21 scientists and assembly building, is an eye-opener. This even led to the end of Brazil's space research program. Let's talk about quality in software. Rocket is an automated vehicle. Once launched, we don't have any control over the rocket. It is controlled by onboard computers. It is necessary to ensure the rocket software is also flawless. An independent team verifies the entire software. A minor error in software led to the failure of PSLV-D1 flight. NASA's Climate Orbiter to Mars also failed due to a small error. The design team had designed systems with British units, that is pound as the unit for mass, whereas commands were given in SI units, that is kilogram as the unit for mass. This error led to the loss of Mars orbiter. Well, the next time when you're watching IPL being held in Dubai, sitting in your living room, just remember that a satellite was sent to orbit flawlessly by a rocket, all by ensuring quality. It is being continuously monitored and operations are carried out to maintain it in orbit. As Henry Ford once said, quality means doing it right when no one is looking. Well, we should do right things even when no one is monitoring us. Thank you.